Hello everybody and welcome back. We are continuing our Redis server. In the previous videos we made a lot, but basically we are opening a TCP IP connection for client, and the client can connect to our Redis server using the default port for 6379. We have a load and dump function to have our custom database. It's a simple one only with key, list, and hash maps. And we have our server class, which takes care of running and shutting down the server. We are also having multiple clients. That's why we are using Atomic. So in the idea, when we are done, we can use it with multiple clients. And we were doing command handlers last time, so I want to continue on it, but first I want to make some changes because we will use this use cases and there's a lot of them. You can see only like command is 3. We have key value operations we implemented the last video. There's already like 4, 7 maybe. And this list operations and hash operations will make our command handler even longer. So off the screen, I decided to change it, and I made some custom functions. I was like thinking, how can I do this? So I already explained how they work in the last video, so I will just be copying and pasting what I did for common comments, and I will explain why they are better and how they work. So instead of having in the ping list, maybe ping is not the good example, but let's say in the set command, we are checking for if we have enough tokens, and then we are giving a response, and then we are checking for databases. So let's not do that. For common commands, for example, handle ping, handle echo, and handle flush all, I already implemented them. And to have them in the process command function, instead of these, we can just say this, which makes it shorter, takes less space. So if our command is ping, the same as we were checking it before, we will just go to handle ping command, giving it tokens and database arguments as arguments, and then in handle ping, we will say, okay, let's return pong. Same for handle echo and flush all. Also, I implemented the key value operations between set, get, keys, type, delete, expire, rename. So I will also be copying and pasting them. So until here, as you can see, it is already half of the width, half of the size, so it takes less space, it will look cleaner. And I also just the same functions in custom functions. I don't want to explain everything again, so I will just copy and paste what I did before. Yes. So we have common commands, we have key value operations, handle set, get, keys, type, delete, expire, and rename. What was it? I think it was just rename, right? Let's check our database. And yes, we have the name function. And these are supposed to work same as the previous implementations. And we are just making it look prettier. but we will continue with list operations in this video, which we already talked about how they are which comments we are supposed to have. We will have list length, list push, list pop, list remove, list index, and list set. And I will continue the same way. We will have else if statements. Then we will be handling each command in the custom function on top of process command function. Also, as you can see, I am not getting all these names in my command handler class in the header file because I don't need to. It will be like they will be used as local functions only that is be using in the Redis command handler.c++ file. So I guess this is enough explanation. Okay, so let's go to our database class and see and just talk about what we will be doing. So like I said before, we will do some list operations. I think this video is long enough it will be long enough just to get the statements here, which basically we will have a ton of command checkers. We will just check if command is something. In that case, we will be returning something. And so when we return something, we will also be checking our database class for that function. That's where we implement the function. This is in the database class. As you can see, we already had some key value operations in the last videos. And these are the function bodies. So I will be adding even more to these. After the key values, we can also add list operations. So rename is the last one, I guess. And then we will have our list operations and they will be implemented here. Okay, so let's do the boring work. Just say if command is L something, then we will do that. So we will have, I can open the use case on the site. I just want to see the names. So if we have L length, that means we will just return a function called handle LLEN function, which we will give the tokens and database, just like others. And then we will be, of course, needing to implement the functions. For now, I think first I will start by list operation functions, then we can add them in the command processor. So I will say static string. These are starting with static standard library string because we are returning strings. So even the names of the handlers will be almost the same. So I will have something basic, generic, saying handle something. And in that inside, we will have a vector of strings. Address. Oops. That we will be receiving the tokens from the processor, and then we will be also having our database DB address of that. And this is basically what we are having in each of them. And of course, they will be returning something at the end. And yeah, that's basically what we want. And we need 1, 2, 3, 4, 5, 6. So we need 8, I guess. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, I think 8 is enough. So I will just copy and paste this 8 times. And 2, 3, 4, 5, 6, 7. Okay, so the first one will be the handle LLEN, like we already put it in the if-else case. So second one will be the LPUSH. Then we will have RPUSH. We will have LPOP. We will have RPOP. We will have LREM. And we will have LINDEX. And we will have LSET. Okay, so we will come back and implement these, but let's quickly copy and paste this too, or an empty one, else if cmd equals, let's leave it empty, and we will return handle something, and we'll have tokens and database as arguments. Again, I will copy this 6 times. Okay, so we need to handle list length. What is the order? LPUSH. In that case, we will say handle LPUSH. Then we have RPUSH. We will say handle push. We will check for LPUSH, RPUSH, LPOP, RPOP, handle LPOP, RPOP. And what's next? We have LLEN, which will handle LLEN. We have LINDEX, which will handle LINDEX. And we have LSET as the final one. Let's not make typing errors. And yes, we have key value common comments, that key value operations, list operations, and hash operations will be coming here. Also, previous video we were returning responses, but as you can see, we don't use it anymore. And we can just change these saying return. There's nothing even left here. No need for extra databases. And we don't need this response variable anymore because we will be getting them from the individual command handlers. And so let's go and start handle length. So most of them, I guess they will have the same beginning because you can check the use cases and how they are working. And of course, for most of these, we will be needing at least 2 or 3 or even more tokens. And we will have, as shown in the other ones, token token check before calling the function. We will say, is this token sizes enough for our function? For example, handle length will be looking for 2 because it needs a key, and if we don't have that, key, then what's the point? Then we will just return an error, requires key, return new line. And we will have something similar for each of them. So after the first one, I will be copying and pasting that part, just showing once is enough. And for this case, we will have a size t length, which will be in the database LLEN function. We don't have it yet, we will have it. And I will give it tokens index of 1. And then we will return saying std to string length, and we will then give it, because we will be returning length from the database. We don't have it yet, as I said, but we will have it. So, and yeah, we will be we can also actually call the name while we are here. So I will say size t LN function, which will be looking for constant string. We're looking for keys. As you can see, we will be returning size t length, and then we will make it string, and it will be our response or return what we will be returning to the process command handler processor. So let's go to the push. Again, we will be checking for how many tokens we have. In push, we will needing 3 at least, because LPUSH requires key and value. If that's the case, we will have a function. Our LPUSH function will be void type because it needs to return anything. It just needs to push it into the list. So again, we will having a key, and this time we will be also needing a value. So just copy it. We will be have a key and value, and when we call it in the command handler, we will say database.lpush, and we will give it tokens index 1, tokens index 2, and to make sure we successfully push it, we will be getting the length, and tokens 1, and in the return we will be returning just like the first one. We will have a colon, and then we will say string to string, and you will give the length plus return new line. Okay. Because LPUSH adds an item to the list, and this is just all. You can always check in the comments, check the comments how they work in the Redis website. It receives a key and element, like I said, and that's all. When you push it, you will return the length of the list after the push operation, which is what we are getting here. I already checked them, so I will not be checking each of them singly. Let's just continue RPUSH, which is very similar to the LPUSH, so I will just copy the name and change L to R, and it is the same thing. While we are here, maybe we can also do more, and I also want to do LPOP, RPOP, LREM, LINDEX, and LSET, or whatever is in the list. LPUSH, RPUSH. Okay, let's do LPOP, RPOP. There will be Boolean, LPOP, and they will have, same as others, the constant tokens, which will be our key. And this time we will be checking for the removing the value, so we don't want constant, we just want the, in the plain version, string address of the value, and RPOP is the same as LPOP, just making sure everything looks fine. We will have LREM, which will be integer. It will be removing specific element, and it will return it will return an integer showing the number of removed elements. So integer reply you can see here. That's why it has integer, LREM, and this time it will have the key, the count number as integer, and then the value. And exactly just like this. Plus we will have also a int count for the number of the element we want to remove. So I might make a mistake somewhere here, so don't focus on too much. If I make a mistake, I will fix in the future. Maybe you will see or not, but it happens. You can make mistakes on programming. You will make mistakes in the programming. There's no other way. And this will be same, but this time we will not remove it. So just get it. I can just copy it. So we know we will have the same constant key every time. As you can see, it's in every one of them. And this time it will not be the count, but will be the index, because we are doing LINDEX. And I think index, and last one, LSET. Again, it will be a Boolean, and it will be almost the same as the LSET, LINDEX, because if you check the read use case, it updates an element in the given position. and you modify it, but this just gets it. So index doesn't change the variable, so I think we can say constant before that. But for when we change something, we cannot put constant at the beginning. I think this concludes our list operations in the database at least. So now let's focus on adding these in the handler functions and go fast. So I will just copy and paste this. Actually, it will be also the same for, okay. If it's less than 3, we will say we need a key and a value, and we will be saying database RPUSH, and we will give it the tokens 1 and 2, and we will have the same as this one for our return case. After pushing, we will just getting the length of the token we pushed, and we will be returning it. So it's like these two are almost the same, just some letter differences between L and R. And let's do LPOP and RPOP, which will have again the same beginning. So I will just copy and paste it. But this time it is if it's less than 2, and we will say LPOP requires a key that we will be popping, removing. And this time we will have a value, and we will have a value, and we will be checking if in the database LPOP, because we did it here, it is a bool, so we will check if it's successful, and we will say if the LPOP with the arguments as token 1 and our value is returning successfully, it's a boolean. And if that's the case, we will say it is a string, so std to string. We will give it the size of the value we have, and we will give it return new line, plus we will give it the value we have, and we will give it return and new line. And if it doesn't work, we will be returning $sign -1 return new line. And this is what is the body of handle pop looks, LPOP. And it will be very similar to the RPOP, so I will just copy and paste. We will be returning L with R there and here. And we need a plus sign here. So here. Okay, so we have only 3 left, and 2 of them are they? At least they're similar now. We can just copy and paste most of the stuff. And again, I will get the first part. And okay, LREM, where is it? Okay, LREM will be checking for key, count number, and value. So we will need 4 token size, which is, we will say, LLEN requires key, count, and value. after this error check, we will say try get the count as integer. It will not be integer, it will come as string, so we will return it to an integer, and we will get the removed number LLEN, which has, of course, the key as tokens index 1, our key. We have the count as count, and we have the value, which is tokens index of 3. Yep. The first one is the key, second one is the count, third one is the value. Why are you not happy about this? Oh, it's a constant. Okay. That's not the end of the world. I will fix it later. Should I just say constant? Okay, let's just say constant and we can deal with it later. And yeah, after we have the tokens in, we call it in the database function, we will just return successfully saying string string removed. If we can remove, but we also need to be able to catch the problem if it happened, the exception. If we have an exception, we will just return saying error valid count, meaning we don't have that count in our database, and that's all. To handle index, list index, we will say, okay, we need 2 variables, right? Yes, we will have the key, index, and value. So if it's less than, we will say list index requires key and index. And index requires a key and index. And that's true. And even the same beginning is quite similar, so I will just copy and paste it. What we have, so same as the LLEN, we are getting integer as the second index 2 of value, but this time what we'll be doing is different, so no need for this, and our will be invalid index, not invalid count. Okay, so here we are getting our index number, integer. We also have a string called value to get our value, and we will be checking if in the database LINDEX function, when we give it the tokens index 1 and our index with the value, it will, if it is okay, it means if it is true, it will be returning a string saying, we go to file, it will be returning a string and it will say size of our value plus return a new line plus value, and again return and new line. In case of success, that's what we are doing. In case of fail, it will return 0. So we will go to our else part and we will say there's been an error. So we will return -1 with return and new line. And if we catch an error exception, we will say, okay, we have a invalid index, or the LINDEX function just doesn't work. What happened? And our value here is not constant, so I will just remove this. Maybe I made a mistake, giving them opposite. I don't know. Okay, let's do the last one. I'm excited. And again, I will just copy the first line because LSET. LSET will ask for 4 values, and it will say LSET requires key index. We'll have key index and value. And again, we will have a try catch. We will try to get our index just like the other ones. std, string to integer, index 2, the tokens. We will be checking if whatever we have in the database's LSET function, which gets the key, the integer index, and the value, which is index in the tokens. And then we will be returning, okay, if it all works fine. Again, I have a problem. I guess that's because of the same mistake again. It wants a constant. Yes. Okay, so let's just say constant there. It will not cry here. And if it's wrong, we can fix it later. Okay, so if our LSET boolean returns 2, we will say everything works, it's fine, okay. Else we will say no, not everything is okay, so we will be returning minus error and like something like index out of range. Else turn here. If we have another problem because of the exception that happens in the try part, we will say exception. We can just return another error saying invalid. I mean, this will be called in case of like if token index 2 is not an integer but turns out it's a string or like something random. It will not be able to turn it into an integer for the index, so it will just say, okay, invalid index. But that's for error handling. But what we do here is, this is the result that we want from the database. That's the important part. And this is like, this is the same for all of them. Okay, so we created list operations in our process comment function. We made the handlers for each comment, for the list comment, and we implemented the handle bodies, which is longer in the function, in the file, but looks prettier in the function. I would say it is more decent. It takes a lot less space than giving it its body in the under the curly braces. So, and we also declared the names for the operations, but we don't have the bodies yet. We will have them in the next video. I think this is a good stopping point. Thank you for watching. Next video we can do list operations function bodies, and then we can continue with HOSH operations, and then we will be getting close to be finished. Thank you for watching. See you next time.